Dear students, myself R.Karthikamani, working as an Assistant Professor, Department of Electronics and Communication Engineering, Sri Ramakrishna Engineering College. Welcome to the course on Embedded Systems. Let us see the introduction about ARM microcontroller. The ARM microcontroller stands for Advanced RISC Machine. It is one of the extensive and most licensed processor cores in the world. These processors are specifically used in portable devices like digital cameras, mobile phones, home networking modules, wireless communication technologies and other embedded systems, due to the benefits such as low power consumption, reasonable performance, etc. The ARM architecture processor is an advanced reduced instruction set computing machine and it's a 32-bit reduced instruction set computer microcontroller. This ARM is a family of microcontroller developed by makers like ST Microelectronics, Motorola, and so on. The ARM architecture comes with totally different versions, like ARM version 1, ARM version 2, etc., and each one has its own advantage and disadvantages. Moore's law is a prediction formulated by Gordon E. Moore in 1965 about transistor density on integrated chips. The law has been remarkably accurate from 1965 to 2013, with transistor density doubling roughly every 2 years. Since 2013, the trend has changed slightly, with transistor density now doubling every 3 years, instead of every 2 years. The figure shows the general ARM architecture, and it has arithmetic logic unit, booth multiplier, barrel shifter, control unit and register file. LPC 2148 microcontroller belongs to ARM 7, Advanced RISC Machine family, means that the ARM is basically an architecture that is used in microcontroller and processors. The word RISC stands for Reduced Instruction Set Computer, as its name shows that it is just like a small or mini controller, which works on the basis of less instruction, as compared to other conventional microcontrollers. This LPC 2148 microcontroller used the 16-bit or 32-bit set instruction architecture for real-time emulation. It also contains the embedded trace support for combing the microcontroller to high-speed flash memory, whose ranging between 32 KB to 512 KB. Its unique accelerator architecture structure and 128 KB wide memory enables the code execution at high clock rate. What does mean ARM7 TDMI? In ARM7 TDMI, ARM stands for Advanced RISC Machines. 7 stands for version number of the architecture. T stands for thumb, 32-bit wide instruction words, 16-bit wide memory. D stands for debug, 2 breakpoints to stop the CPU, both hardware and software. M stands for multiplier, enhanced 32x8 multiplier. The LPC 2148 microcontroller is designed by Philips NXP Semiconductor, with several inbuilt features and peripherals. The ARM-based microcontroller has 3 types of buses. They are 1 AMBA bus, 2 local bus, 3 VPB bus. The figure shows the general architecture block diagram of LPC 2148 microcontroller with all their essential parts. ARM-based LPC2148 microcontroller has 45 general-purpose input-output pins. The operating voltage of these input-output pins is 5 volt. This highlighted portion shows the CPU of LPC2148 microcontroller. The CPU core used in this LPC2148 microcontroller is ARM7 based RISC architecture. An interrupt is a signal sent to the CPU, which indicates that a system event has occurred, which needs immediate attention. All input requests are received by vectored interrupt controller and it converts them into fast interrupt request. We must know interrupt service routine or ISR. It is a special request to the CPU to execute a function, small piece of code called as ISR, when an interrupt occurs. When an IRQ arrives to the CPU, it stops executing the current code, and start executing the ISR. After the ISR execution has finished, the CPU gets back to where it had stopped. Every peripheral device consists of single interrupt line allied to the vector interrupt controller, although can have various interrupt flags inside. Individual interrupt flags can also signify one or more interrupt resource. This LPC2148 microcontroller has one 10-bit digital to analog converter or DAC. This converter converts the digital input into analog output. The maximum DAC output voltages are called VREF voltages. Power down mode and buffered output is also available in this digital to analog converter. This LPC2148 microcontroller also contains 2 analog to digital converters, whose names are ADC0 and ADC1. There are 14 total number of inputs of ADC are available. This LPC2148 microcontroller contains 2 UART, whose name are UART0 and UART01. UART stands for Universal Asynchronous Receiver or Transmitter. It's not a communication protocol like SPI and I2C, but a physical circuit in a microcontroller, or a stand-alone IC. A UART's main purpose is to transmit and receive serial data. These UARTs are provided the full mode control handshake interface during transmitting or receiving the data lines. These are used 16-byte data rate during transmitting or receiving the data. For covering wide range of baud rate, they also contain the built-in functional baud rate generator, therefore there is no need of any external crystal of specific value. In UART serial communication, the data is transmitted asynchronously, i.e. there is no clock or other timing signal involved between the sender and receiver. Instead of clock signal, UART uses some special bits called start and stop bits. These additional bits allows the receiving UART to identify the actual data. In UART communication, 2 UARTs communicate directly with each other. The transmitting UART converts parallel data from a controlling device like a CPU into serial form, transmits it in serial to the receiving UART, which then converts the serial data back into parallel data for the receiving device. Only 2 wires are needed to transmit data between 2 UARTs. Data flows from the transmit pin of the transmitting UART to the RX pin of the receiving UART. The UART that is going to transmit data receives the data from a data bus. The data bus is used to send data to the UART by another device, like a CPU, memory, or microcontroller. Data is transferred from the data bus to the transmitting UART in parallel form. After the transmitting UART gets the parallel data from the data bus, it adds a start bit, a parity bit, and a stop bit, creating the data packet. Next, the data packet is output serially, bit by bit at the TX pin. The receiving UART reads the data packet bit by bit at its RX pin. The receiving UART then converts the data back into parallel form, and removes the start bit, parity bit, and stop bits. Finally, the receiving UART transfers the data packet in parallel to the data bus on the receiving end. I2C bus is bidirectional multi-master bus. The I2C protocol is used to establish communication between two or more ICS, integrated circuits, hence why it's known as inter-integrated circuit or I2C communication. However, it should be noted that I2C could also be used as a communication protocol between two ICS that are located on the same PCB. It can easily control two or more buses, which are connected to it. The data which is transferred from master bus to slave bus, through this bidirectional bus at baud rate up 400 kbytes. Similarly, the serial clock synchronization allows the device to communicate the data of different baud rate pass through only one serial bus. This clock synchronization could be used as handshake mechanism for resuming or suspending the data transfer. SPI, Serial Peripheral Interface, is an interface bus, commonly used for communication with flash memory, sensors, real-time clocks, analog to digital converters, and more. The Serial Peripheral Interface, SPI, bus was developed by Motorola to provide full duplex synchronous serial communication between master and slave devices. This SPI serial I/O control supports the duplex data transfer, means this control supports the device for transferring the data, whose range 4 kilobytes to 16 kilobytes, from master bus to slave bus. This operation is called synchronous serial communication operation, from master bus to slave bus. This data is transmitted, or received in 8 frames, and each frame contains 4 bits to 16 bits. The figure shows a standard SPI connection, which involves a master connected to slaves using the serial clock, SCK, master out slave in, MOSI, master in slave out, MISO, and slave select, SS, lines. The SCK, MOSI, and MISO signals can be shared by slaves, while each slave has a unique SS line. One unique benefit of SPI is the fact that data can be transferred without interruption. Any number of bits can be sent or received in a continuous stream. With I2C and UART, data is sent in packets, limited to a specific number of bits. Start and stop conditions define the beginning and end of each packet, so the data is interrupted during transmission. Devices communicating via SPI are in a master-slave relationship. The master is the controlling device, usually a microcontroller, while the slave, usually a sensor, display, or memory chip, takes instruction from the master. The simplest configuration of SPI is a single master, single slave system, but one master can control more than one slave. This LPC 2148 microcontroller has 2 timers or counters. These timers are 32-bit wide, and are programmable with 32-bit prescaler value, as well as it also has one external event counter. Each timer has 4 32-bit capture channels, which take the snapshot of timer value, during the transition of any input signal. With the help of this capture event, the interruption could be also generate. This LPC 2148 microcontroller also contains the watchdog timer, whose main purposes is to reset the microcontroller within specific amount of time, during erroneous state. After this state it again turned on the microcenter within specific amount of time limit. Let we discuss some applications of watchdog timer. An application in mobile phone is that display is off in case no GUI interaction takes place within a watched time interval. This will save good amount of battery power. An application in temperature controller is that if controller takes no action to switch off the current within preset watched time interval, the current is switched off, and warning signal is raised as indication of controller failure. Failure to switch off current may burst a boiler in which water is heated. If software hangs due to some bug/issue, it helps to reset the system automatically without any human interactions. There is growing demand for real-time technology in the consumer electronics and automotive sectors. Likewise, compact real-time clock modules are gaining widespread application in a range of products that require clock functions. In this LPC 2148 microcontroller, the RDC is designed to set the counters for the measuring the whole time, when the controller is in operating mode, or idle mode. It has designed to consume little power, which make it suitable for battery-powered systems, where CPU is not continually in operating mode. RDC ICs play an important role in IoT applications, ranging from multi-core smartphones to small connected sensors. In these devices, power and accuracy are critical factors. Real-time clock ICs offer extended battery life to IoT devices, which is the fundamental requirement for all these devices. In IoT applications, it is required to keep updates regarding communication time slots and event occurrences, which is achieved by using a small battery or capacitor. Initially, real-time clock ICs were used to track time and provide information related to time and data in a more usable manner than a simple clock counter. With technological advancements, manufacturers are continuously introducing new features such as embedded memory, alarms, timestamp recording, and watchdog. This LPC 2148 microcontroller contains the on-chip integrated oscillator which operate with an external crystal, whose range is in between 1 MHz to 25 MHz. Its output frequency is called FOCS and controller clock frequency is called CCLK. These names are used for making rate equation. These frequencies would be same when the PLL is connected and in running position. This LPC 2148 microcontroller contains two phase locked loops, whose names are PLL0 and PLL1. The input frequency whose range is in between 1 MHz to 25 MHz is accepted by this PLL. This frequency range could be extended from 10 MHz to 60 MHz by using the current controlled oscillator, CCO. ARM7 LPC2148 microcontroller needs two clocks, one is for its peripherals, and other for its CPU. CPU works faster with higher frequencies, whereas peripheral needs lower frequency to work with. The peripheral clock, PCLK, and CPU clock, CCLK, gets clock input from a PLL or from external source. It has power-saving modes, also like idle mode and sleep mode. In idle mode, only the clock provided to CPU gets deactivated, whereas peripherals clock will remain active in this mode. Next is sleep mode. The computer cuts power to unneeded subsystems, and places the RAM into a minimum power state, just sufficient to retain its data. A computer must consume some energy while sleeping, in order to power the RAM, and to be able to respond to a wake-up event. The next topic is about memory interfacing with ARM microcontroller. In memory interfacing, let we see how to interface SD card with LPC2148 microcontroller, using SPI protocol. SPI interface uses 4 wires for communication. Hence it is also known as 4-wire serial communication protocol. SPI is a full duplex master-slave communication protocol. This means that only a single master and a single slave can communicate on the interface, but at the same time, SPI-enabled devices work in 2 basic modes of SPI operation, i.e. SPI master mode and SPI slave mode. Master device is responsible for initiation of communication. Master device generates serial clock for synchronous data transfer. Master device can handle multiple slave devices on the bus by selecting them one by one. The 4 signal lines are used for communication. They are chip select or CS pin, used as host to card chip select signal. Clock or CLK, host to card clock signal. The third pin is MOSI, master out slave in, host to card single bit data signal. And fourth one is MISO, master, in slave, out, card to host single bit data signal. Let's see what is memory in microcontroller and its working in ARM microcontroller. The bus cycle is the cycle, or time required to make a single read or write transaction between the CPU and an external device such as external memory. The ARM7TDMI processor bus interface is pipelined. This gives the maximum time for a memory cycle to decode the address and respond to the access request. The ARM7TDMI processor bus interface can perform 4 different types of bus cycle. A non-sequential cycle requests a transfer to or from an address, which is unrelated to the address used in the preceding cycle. A sequential cycle requests a transfer to or from an address, which is either the same, 1 word, or 1/2 word greater than the address used in the preceding cycle. An internal cycle does not require a transfer, because it is performing an internal function, and no useful prefetching can be performed at the same time. A coprocessor register transfer cycle uses the data bus to communicate with a coprocessor, but does not require any action by the memory system. Let we summarize the topic discussed in this session. Dear students, in this lecture we discussed about ARM LPC2148 microcontroller architecture, and its functional blocks, types of buses, memory interfacing, and bus cycle types. Thank you.